Hi, everybody. My name is Alan Lee. I am a team member of the ETC core. Today we are going to talk about the smart contracts on blockchains. So firstly, we'll talk about the overview of smart contract, what it is, and its history, and what can it do. And then we're talking about some properties of smart contracts on the blockchain. What are the limitations of the smart contracts, etc., and what are the challenges? And then finally, we're going to talk about the EVM LLVM project that I'm working on. So what is a smart contract? A smart contract is actually has been there for a long time. It is firstly proposed by Niels Gabel in its early 1990s. At the moment, it is characterized as a computerized protocol progress, which runs automatically and without interferences as an agent or median between several parties. Its execution is supposed to be very independent, irreversible, and finally, very importantly, verifiable. So people can go without any actual human being as the agent, because human beings are error prone and may cause other troubles. And these days, smart contracts finds its best home, which is blockchain. Because of the property of the blockchains, smart contracts runs on blockchains is the best solution for smart contracts. It records all those states on blockchains, and because because blockchains are being executed around everywhere around the world, it is verified by replication. A lot of people around the world can help you to verify your smart contracts. It is supposed to disrupt traditional business because smart contract is so disrupted. If people think that it will eventually change everybody's life, but it is not there yet because at this moment, smart contracts people just started to develop smart contracts. There are a lot of limitations, such as it's slow and expensive to run and it's error prone, etc. It forbids smart contracts being used in a big varieties of aspects of our daily lives. But blockchain infrastructures are becoming more and more mature. So as time goes by, we'll eventually see more and more adoptions of smart contracts. Let's take a recap of smart contract workflows. So basically, from now on, we are going to dig into the execution of a smart contract. So on the right-hand side, you can see that a blockchain is actually cannot actually execute a smart contract source code. It has to use a smart contract compiler to compile the source code into machine-readable bytecodes. On an Ethereum classic or Ethereum family blockchain, the compiled contract will have two parts. The first part is the API, and the second part is the actual deployable codes, which will be put onto the block in the blockchain. So at this moment, you can see that there are two very important components of a smart contract execution engine. The first one is the smart contract compiler, and the second one is the virtual machine that's going to execute the smart contract. You can see that they are both independent, and blockchain is supposed to be agnostic of the smart contract compilers. The smart contract is being used. On ETC and ETH, the EVM, which is short for Ethereum Virtual Machine, is the federal execution environment protocol being used on these two blockchains. Notice that it's a protocol. There are many multiple implementations of the EVM for different blockchain. Let's say on ETC, we have spun EVMs, ETH, they have gas, etc. So you can even write your own VM as long as your implementation is conformant with the EVM protocol defined in the yellow paper. it tries to execute the blockchain's assembly code, which is EVM bytecode. You can think of it as Java bytecodes or WebAssembly bytecodes. It's just those bytecodes will be more machine readable. Also notice that the virtual machines do not assume of the compilers is being used. You can use whatever compilers there available as long as they generate correct and executable bytecodes. Also, the second one is the smart contract compilers in the execution environment. It tries to compile the smart contracts into EVM bytecodes. It also optionally checks for the contract to see if there are many errors, significant errors, easy spotted errors, and it runs independently of the virtual machine. And also, you can have many compilers to choose from. Because we are going to execute on a blockchain, so we have to go with the blockchain properties. Generally speaking, there are some limitations to execute a smart contract on a blockchain. The first one, and the very important one, is the determinism of the smart contract programming language. Because remember that the smart contract will be executed many times, and we have to guarantee that each execution has to have exactly the same result. Otherwise, we'll have a blockchain fork. So because of this, because of the determinism is required, we can, at this moment, we cannot have heaps in our program. We cannot do garbage collection. We cannot do multi-threading, etc. Also, we cannot have floating point supports or runtime linkage because they are all going to introduce unforeseeable runtime behaviors, which will break the determinism which is required by the smart contract. And of course, the smart contract will be there for many years. So we have to make sure the platform is future-proof and also hardware independent, because we are not going to know which hardware the smart contract is going to execute on. Maybe it's on a Raspberry Pi 4, or maybe it's on your daily computers. We don't know about it, so we cannot make any assumptions. The smart contracts may be susceptible to economic attacks, so it has to be attack-proof. There are many different types of attacks. So, for example, dead loops or G-bounce, gas attacks, whatever, a lot of things might happen to the smart contracts. Also, the performance of the smart contracts is very important because in a single block, there are only a limited number of smart contracts can be put into a single block. So, and it will be executed across the globe in many people's computers. So the cost of the execution is very expensive. Because of this, people just design that each instruction costs some amount of gas. So, and then we specify only a limited amount of gas. So in order to avoid the halting problem, in order to avoid the dead loop problems. Also, storage costs gas because on the blockchain, everything is limited. The resources are limited, the storage is limited, and the execution time and the CPU slots are limited. So, so everything costs gas. Gas makes sure that the program is running economically. So because of this, the performance of the smart contracts is very important, and people are trying continuously to improve the performance on the computer or on the smart contracts. Also, we do not forget that security is also very important, maybe more important than performance. You may have heard that 1 or 2 years ago, there are many tokens, ERC20 tokens being hacked because they did not implement the safe mass library, also so that the attackers use the underflow floor to cause the token to crash, to generate a limited amount of the tokens. So those kind of things are software vulnerabilities that we had to avoid, because it will cause a lot of a lot of economical impacts. For example, on the right hand side, you can see that the DeFi, the value, total number of values, US dollars in DeFi is actually being increased over the years, even though we have a drop early this year, but it's increasing steadily otherwise. So this is really important because we have reached 1.2 billion US dollars at some point. So that's, well, if the blockchain crashes, or and the result will be really bad. So because of this, smart contracts makes a lot of assumptions. For example, it must be deterministic to avoid unforeseeable behaviors, to avoid a lot of those attacks from the outside. Because of this, at this moment, we only have two kinds of smart contract languages on the Ethereum family. The first one is the widely used Solidity languages. The second one is the Viper languages. And there are no other smart contract languages around the community. So actually, if you compare to the real world industry, where a lot of languages are being widely used, for example, C and C++, Rust, Golang, etc., or Python. So you can see that there's a scarcity of the languages there. Actually, we think that the languages are really important in this job to create smart contracts, because unfit languages will drastically increase complexity and vulnerability of the program you run. And also, the general purpose languages are not suitable for all tasks. You might have your very own specific task that is best to be done in vertically domain-specific languages. Those kind of languages will exactly designed to solve specific problems, and it will try to reduce the time complexity of the development and maintenance of your future programs. So because of this, I think the smart contract community is still at its very early stage, where people are still relying on only a few smart contract languages to develop their jobs. At this moment, there are only 3 compilers which can compile higher level languages to a smart contract. The EVM LLVM compiler, we're going to talk about a little bit, and the widely used Solidity compiler and the Viper compiler are the options that you can only have. In the future, I think smart contracts will improve its performance, especially when we say performance, I also include the security. We'll try to, I think the smart contract in the future, people will try to verify the smart contract on blockchains using cryptographic approaches, which will which will make the scalability of the smart contracts larger. The second one is that people will try to improve the smart contract and execution environment. For example, improved compiler to make it consume less gas, to improve the VM so that it execute faster. And also we might have other architectural improvements to have compiler and virtual machine code design to make sure that the development pipeline goes more smoothly. And on other things, like smart contract will have more functionalities in the future for sure. For example, cross-blockchain communications, oracles. Now we have some oracles implemented already, but I think we want in the future, we are going to see more stable external message interchanging mechanisms being invented. The third one is very important as well. We are going to see some stealth contracts being deployed on the blockchain, so other people are not going to see what is going on in this stealth contracts. This is also very useful. So in the future of smart contracts, people are going to improve the software stack security by code verifications. And so in this case, there are many ways to prove your smart contract is secure. Most of the approaches are going to examine your source languages. For example, if you write your smart contracts in Solidity, there may be some Solidity specific code verifiers that scans your source code and take a look if there's any problems with it. And also there are some VM specific code verifiers which checks if there are any obvious jumps to a non-target, which is deemed as invalid jumps. Those, as we talked about before, the security of the software stack is very important. People will put more and more efforts into the code verifications to ensure that in the future we are going to execute the smart contracts safely. Also, the performance will improve as well. We'll try to run the smart contracts faster, will make it have less gas consumptions. And the third one, I think, is the improvements in the smart contract languages. As I said, we want to see more and more domain-specific languages as the compiler framework matures. And we want to have better compilation results because of the language improvements. And we want to have compiler and virtual machine code designs so that the whole architecture executes better and more efficiently. And we also want to see more blockchain layer improvements so that the blockchain can improve itself, and then the smart contract execution environment can evolve with the blockchain. Because of this, the ETC core is building a project called the EVM LLVM. It's the project that I'm working on, so I want to introduce a little bit about it to everybody. I think this is a very important project that the ETC core and ETC lab is going to contribute to the Ethereum family. ETC core's EVM LLVM backend project is actually a new LLVM backend that compiles existing languages to EVM bytecodes. Let's say you have something written in C or C++, and then when you want to compile it into machine executable programs, you will use GCC or CLAN. And LLVM project is actually behind CLAN. CLAN is part of the LLVM umbrella project. So LLVM is really big. It has been there for many, many years. The goal of the EVM LLVM project aims at bringing the state-of-the-art compilation technology used in LLVM project to the Ethereum families. We based our development on the latest LLVM 10 release, which is released in March 2020. And we will try to embrace the huge and vibrant LLVM community that is around the globe. A lot of brilliant compiler developers are contributing to LLVM projects daily. Because of the LLVM support, we are going to support multiple and new language front ends. So the smart contract developers will not rely only on the Solidity and Viper smart languages. They can create their own languages, the domain-specific languages, or use existing languages such as C and C++, etc., for their smart contract development. Also, very importantly, we want to make the LLVM existing ecosystem available to the blockchain society. The LLVM ecosystem is huge. It consists of a lot of very useful compiler projects. The optimizers, the verifiers, and a lot of the tools that will be very beneficial to the smart contract developers. We want to bring those existing very helpful ecosystem to the blockchain so that every people of the smart contract developer community will benefit. Also, we want to point out that building projects based on LLVM will be future proof, because LLVM has been developed for more than 20 years, and then it is still the go-to compiler infrastructures for new architecture. For example, nowadays you will have you have a smartphone, the OS of a smartphone compiled by LLVM, and you have your latest chips, program of your latest chip compiled by LLVM, etc. LLVM is the most widely supported compiler framework around the world, and it's attracting more and more brilliant developers to contribute their new ideas to the compiler framework. I think it's hard to miss the LLVM ecosystem if in the blockchain society. Also, for example, if you are using Chrome, Google Chrome, or Safari, that's actually there are potentially some LLVM components inside the browsers or your daily iOS or Android phones. I want to introduce one of my one of the articles I've written recently about the EVM LLVM project. It's you can Google it to see to read it. It's called "Creating Your Own Smart Contract Languages Using LLVM." Because LLVM has its very stable and widely accepted intermediate representation, so any people who wants to develop a new smart contract language could basically write your own smart contract language front end and compile and write a parser to compile the front end source code into LLVM IR, and the LLVM EVM backend will take over the LLVM IR, generate the LLVM IR, and turn them into the EVM bytecode, which is deployable to the blockchain. I think this is very interesting and very useful technology that's going to impact the smart contract world, because people would be definitely more expressive if they have a new DSL, which will be more relevant to their projects, etc. We want to talk more about the EVM LLVM project. If you are interested about knowing more about the EVM LLVM projects, you can go to GitHub and search for EVM_LLVM. Everything is open sourced, so please welcome to take a look about it. And we also on ETC Labs Core website, we have the docs of the EVM LLVM projects. And also you are welcome to participate in the discussions of the Ethereum LLVM developer group on Telegram. Just search Ethereum LLVM and they will find us. Okay, so much for the smart contracts. Thanks for listening to me, and have a great day.